to the Hakin channel. So for those of you who are new here, we're just a Melbourne-based teachers who are setting up a YouTube channel for our students. So my video today is to walk you through a bit of an introduction to space for those of you who are learning it this term. So there we are. So today's learning intention is, well, to introduce you to space and just some of the basic concepts that you will be unraveling in this term. The success criteria is to just know where the sun sets and rises, to know how many days are in a leap year, and to perhaps be able to explain why Australia has daylight savings. So there are 8 planets in our solar system. That includes Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. When I was in high school, it was 9 planets. Pluto was included, but now it's considered a dwarf planet. Feel free to pause whenever you need to, just to record these notes down in your notebooks, because I'm not going to stop and pause for you to take the notes. So the Earth orbits the Sun every 300 to 65 days approximately. So this year, 2020, is a leap year. So a leap year occurs every 4 years and has 366 days. So the extra day in a leap year is accommodated in February, because February has 29 days in a leap year, but if it wasn't a leap year, it would have only 28 days. So the Earth is kept in orbit by the force of gravity. Okay, so if you can have a look, this blue sphere, well, circle really, is the Earth, and this yellow globe over here with red surroundings, that's meant to be the Sun. So this image here is just meant to show you that the Earth orbits around the Sun. So gravity also keeps the Moon in orbit around the Earth. So the Moon orbits around the Earth every 28 days. Alright, so you need to keep in mind that the Earth is rotating around the Sun and the Moon is rotating around the Earth. So a really important fact that I probably would like you to know is that gravity is stronger if the planet has more mass. So Jupiter actually has more mass than Earth, as you can see, scale for size. It's probably an incorrect scale, but I'm just showing you that Jupiter is substantially larger than Earth. So on Earth we have, well, I'm sure you know how you feel on Earth, but if I was to carry you, I just put an owl in a book because, well, why not? If you were to carry yourself to Jupiter, you would feel far more heavier on Jupiter because Jupiter has more mass than on Earth. And that's why I made the owl larger. So, how much of the Moon do we see depends on where the Moon is in its orbit. So, Mr. Daffy will go over the phases of the Moon in the next lesson. So I'm not really going to touch on that, but I've just got some images just to show you how when the Sun reflects the light, okay, you can see that there's a bit of a shadow over here and that there's a bit of a light shining over the Moon. But if you were standing over here, okay, you would most likely see the shadow of the Moon. Alright, you wouldn't see this side because you're not on this area, you're on this side. Okay, so that is what we would perhaps see down on Earth, okay, if we were over here. So I've just got a few examples here. As I said, the Moon orbits around the Earth, alright? So that if we were here still and the Moon was rotating, this is what we would see. Okay, now there's special names for them, but like I said, Mr. Daffy will go through that, and then I will take you through a practical on the phases of the Moon. Alright, so here you can see that as the Moon rotates and there's more sun, well, my pen isn't working, so if you see that the sun, the light over here from the sun is shining more, that is why the appearance of the moon has more. You can see more of the moon. But do you see that? There's a special name for that. So the moon is a natural satellite. A satellite is anything that orbits the Earth, really. So artificial satellites have 4 main uses: communication, monitoring the weather, observing the Earth, and exploring the solar system. I'm sure there's also far more sophisticated uses, but for this topic, that's all we really need you to know. So the Earth is tilted on an axis, all right? So this dotted line here, this white dotted line, that's the imaginary axis. We don't actually have a pole sticking through Earth. It's just an imaginary line, okay? So we call this bit at the top the North Pole. Oh. And we call this bit here at the bottom the South Pole, all right? So the Earth spins on its axis every 24 hours, all right? So it's on a tilt. That's what you need to, well, this is my first time using it. That was horrible, everyone. Oh, I really need to practice. I beg your pardon, everyone. So because of because of the spin, the sun rises in the east and sets in the west. So I've got a little picture for you. So here you can see that the first arrow shows that it rises, okay, and around sets at around 3 downwards, all right? So, oh, I don't know what that's it. All right, and this, you probably may have never seen this before, but we will go over this in another lesson. So, the sun appears lower in the winter than it does in the summer. So, if you can see, the sun actually rotates, the Earth rotates so that it actually is higher, okay, in summer. So, we're perhaps getting more sunlight. Whereas in winter, if you have a look at the next dotted line, okay, there are longer shadows in winter, but do you see how that when the Earth rotates around the sun, that it's actually lower? Okay, there's not much sunlight, and that's why we have more shadows in winter. So while the Earth is spinning, the side that faces the sun is light. Okay, so we would say maybe potentially that half would have light. All right, and then everyone here would be sleeping. Okay, so the Earth is divided up into the northern hemisphere and the southern hemisphere. So northern, kind of like how we had the North Pole on top and the South Pole at the bottom, all right? It's also split it into different hemispheres, and this dotted line is called the equator, all right? And there are also other lines here, which we will talk about when we discuss seasons. Okay, so if you want to draw like a diagram of Earth in your workbooks to show the northern hemisphere and southern hemisphere along with the 2 poles and equator, that would be awesome. So the tilt of the Earth on its axis shows us the seasons, all right? So this is just a bit of a date, an example that I've kind of come up with. So if we were to say this side was experiencing winter, what date would it be? June 21st, let's say, because June is found in what season? Winter. Whereas over here, if they were experiencing summer, all right, it would be most likely one of the summer months. Okay, so I've just given a random example. It's just an example. 2 things happen because of this tilt, all right? So the days are longer during the summer, and the weather is warmer during the summer. And that's due to the hemisphere being closer to the sun. So the question is, in Australia we have daylight savings. Why? Well, daylight savings allows us to maximise our usage with the sunlight. That's why our daytime is longer. Okay, and that's why at like 6 p.m. it's not like pitch black. right? It feels like 3 o'clock at 6 o'clock in summer. So I won't be going over the eclipses in detail, but the final thing that I'm going to touch on is the influence of the sun, moon, and earth, and how the order plays a role in the types of eclipses we get. So the 2 eclipses we get is the solar eclipse and the lunar eclipse. And Mr. Chung will walk you through the eclipses, but just have a look at how it's rearranged. So you can see that, for example, the sun is first here, sun is first here. Moon is here, moon is over here. Earth is over here in a solar eclipse. Earth is over here in a lunar eclipse. Okay, and you'll get to learn what the preumbra and umbra means. So stay tuned for that, and thank you for watching your introduction to space.